In this clip, I'll show you, this is the code that I wrote using the algorithm from SOM to cluster, sorry, the data. This one is, you don't need to understand it. This is show all. That is show the data, show all data, and it will show uh, the link of the node in the coordinate layer also. X is the values of data and K is the values in coordinate layer. Okay, so this is I use the structure of this line is the coordinate layer, that the width and the height of the coordinate layer is uh, how many nodes. Okay, so I start with randomly generate k values. Okay, and then I just reshape it into width and height, and I set the learning rate. This is eta, the learning rate. I have three kinds of x. At first I will use x to be like our starting point. So the red one is, the red dot is the position of x, and the green one is the position of the coordinate layer, as you can understood from the clip that I explained about SOM. Of course, we can change it into, for example, if I change it to be x1, this is the data that I make it to be just only two groups here. And the values of k is randomly like scattered around this space. And if I change it to be x2, it will be like this, three groups of the data. So guys, I'll start with x to be the general one first. So you can see that these data, both data and coordinate nodes, are like randomly scattered in the space between 0 to 10. And when we plot the line of the neighborhood, you can see this one is like a mess, right? Okay, so this part is the part of the code that try to learn. So I start with randomly pick up one example and present it to our coordinate network. So this one is the distance layer. This is the distance layer that try to find the distance of the coordinate with the values of x. So I find the distance, Euclidean distance, and then I find the winner node using the argument min, and find the row and columns, or I and j, of this winner. And then I update the weight using this equation. It's quite simple. The weight in coordinate is the original weight plus eta times x. So if I wrote this one, the weight in coordinate will be the original weight plus eta times x. That's all. Oh, sorry. So this is the weight updating equation here. Both winner and this one, I change for eta times x, right? It is, for example, you start eta with 0.1, right? Here you have eta is 0.1. Okay, and I change eta to lower one times eta by 0.3 to be eta of n, and then I update all neighbors here. This is if the location is like can adjust the node above, if it's the row and that is a line above here, update the neighbor above this winner. If this is the like if there are a column to the right of the winner one, update the neighbor on the right. Okay, if there's a node on the left, update the node on the left. Okay, if there are a node lower than the winner, update the neighbor under this winner node. And just if I mod by 1000 is equal to 0, just print the dot. So this is a number of iterations, and just wait for them to complete like 100 dots here, and then you see the coordinate layer and its neighborhood. So wait for a while. Yes, so you can see that we have like the space here. The x the data is still same, but you can see from for the each neighbor or each node in the coordinate is like it try to distribute themselves to cover all data. Okay, so all data here covered by this coordinate node, right? Because we still try to find like the winner one, right? For example, this node is like the, if we represent these nodes to our algorithm, the winner will be the green one. The winner node will be here, this one. So they will adjust. They try to adjust these winner nodes to all nodes in this area. So it will move like slightly move up, down, left, right, but it's still like work around this group. Okay, so we once all coordinates node can cover all nodes, it will like not change so much. So you can see the result like this. Maybe you want to see if we change, or if we present the x1 to this example, to this algorithm, what will happen. So this one is general, like it is scatter for coordinate layer is scattered in this area. Okay, so this one is like the training one, so you can wait. Okay, it's almost finished. Okay, so guys, you can see here there are two like separately two parts. That is this is the first one, this is the second one, and you can see that for the coordinate network, coordinate layer is cover this area and cover this area, so nothing are here. Okay, nothing's here, and try to cover. So all of data here will be covered by the like the coordinate node inside this box, and same as this one, same as this one. Okay, so I hope that you get the idea of how can the SOM work.